Hello everyone, we'll continue our ACI learning with the APIC clustering. In this small video, I'm going to talk about APIC clustering and what exactly it is. Let's get started. In left side of the screen, you are seeing spine and leaf topology, and at the bottom we have three APIC controllers. In order to have redundancy, scalability, and resiliency, we create cluster of APIC nodes. A cluster in ACI is set of APIC nodes. Minimum we can have 3 or we can have 5 or 7 nodes in a cluster. We can also have 4 and 6, but those are different scenarios I will be talking later in this series. Clustering provides redundancy, scalability, and resiliency. Even if the entire cluster is down, the fabric forwarding still works. The cluster is there to configure, manage, and orchestrate the fabric. It is not a part of forwarding in the ACI fabric. So even if the cluster is not available, the forwarding will still go on. Although you will not be able to configure or manage the ACI fabric from the APIC controllers. Clusters always maintain quorum. That means in order to take any decision or in order to configure anything in the fabric, you need to have majority in the clusters. For example, if you have 3 nodes, 2 is the majority or 3 is the majority. So you need to have 2 nodes or 3 nodes available to make any configuration changes in the fabric. If you have lesser nodes available in the cluster, like if you have one node available and rest 2 nodes are not available, then you will not be able to make any configuration changes to the ACI fabric, but still the cluster will be running in read-only state. That means you can see the configuration, but the configuration changes will not be present. To bring back the cluster in read-write operation state, you need to bring back the nodes which are down. APIC configuration database is divided into shards, which is horizontal partitioning of the configuration or the database. Every configuration in ACI or the object in ACI will have exactly 3 copies, and one of that horizontal partition is called a shard. That particular shard which is associated with a configuration or object in the ACI fabric will be replicated to two other nodes. So we are going to have exactly 3 copies of any of the shards which gets created. Every shard will have one main copy and 2 replica copies saved to other 2 nodes of the APIC cluster. Even if we have 5 node cluster or 7 node clusters, shards are going to be exactly 3, not more than that. Let's see a cluster failure scenario. We know that at least 2 shard copies are needed to make any read and write operation in the cluster or the ACI fabric. If we have only one shard object present, the cluster will be in the read only state. So for example, in this particular topology, let's say APIC 1 and APIC 2 goes down, then all the shards associated with APIC 1 and 2 will also go down, and the cluster remaining with just one APIC, that is APIC 3 and its shards, will be in read only state. If you want to bring back the cluster in read write state, you need to bring at least one of these APIC controllers back. To scale the fabric, we also need to increase the number of nodes in the APIC cluster. For example, here I have 5 nodes in my APIC cluster, and with this 5 node APIC cluster, although the sharding is still exactly the same as we have seen with the 3 node APIC cluster, we can see that the blue shard 1, blue shard 2 and blue shard 3 are only 3 copies of the blue shard present here, even though the number of nodes in the cluster is 5. Similarly, the green shard 1 is here, another is here, and the third one is on APIC 5. So we have exactly 3 copies of green shard available, even though the number of nodes, total nodes in the cluster is 5. Similarly, even if you have another APIC here and another APIC here, that will not increase the number of shards in the cluster. It will always be exactly 3. Here I also have a screenshot of ACI verified scalability guide. Here we can see that if the number of epic nodes are 3, then you can have 85 leaf switches in a particular pod. Similarly, you keep on increasing the number of epic node and the number of leaf switches also getting increased. So you might ask the question, if the number of shards are not increasing in epic cluster by increasing the number of node, then what is the use of increasing the number of node? The reason for increasing the number of node is to get higher scalability. Thank you so much. With this, we'll get into the demo of epic cluster.